So you can see here we're working with a lot of circle stuff. So clearly what we have here, I mean, it's just a sphere, right? So let's just give it a name. It's there, but you know, let's not be rude. Let's treat it like the rest. So with the sphere, it's just a ball. It sounds so blunt, but I just want to put it there, you know, net for control, just for vibes. So it's just a ball, you know. So what you want to recognize is when you then have this ball cut in half, you refer to it as a hemisphere. So here, let's just say here, a hemisphere, but you're smart. So you obviously definitely knew that. And you're probably asking, but bro, why are you telling us these things that we know? I'm sorry, okay? Like, I don't want to be that guy that doesn't say stuff and then, you know. So with the hemisphere, obviously, you would only be considering half your circle. So depending on what kind of equation you're dealing with, right? Always keep in mind how you can have an area or a volume of something. But then when you're dealing with half of that thing, always just remember to consider half. Because, for example, things like a circle, obviously the area of a circle is just pi r squared. But if it's half a circle, then it's like half pi r squared. So with the hemisphere, obviously this is the volume of a sphere. With the hemisphere, it's just half a sphere. So it doesn't have its own new formula. It's just half of this. So here, volume is just half of this. You see, nothing crazy, nothing fancy. Of which, if you put all this into your calculator, if you say this, or rather, if you work with the numbers, you're going to get 2 over 3 pi r cubed, which is not a big issue. There's really nothing much to say about a sphere, but obviously the blunt stuff should never be forgotten. You see, you have a radius there, it's the same as the radius length over there. Now there's a question later on that's going to be talking about, you know, a quarter of a sphere, 1/8 of a sphere. So this picture here, you can already see that this sphere can easily be cut into like 8 pieces. So you'll have a piece here, chop it there. This could easily be like one tiny piece there. So obviously the area of this one tiny piece, or the surface area of this one tiny piece, will just be like 1/8 of the whole thing. But speaking of which, right, obviously when it comes to your surface area of like a sphere, that's something we definitely need to discuss, because a sphere also has a surface area, which is what we also need to jot down here. I was busy stalling, thinking to myself, I'm forgetting something. I was like, what am I forgetting? And then I was like, oh, surface area. This just refers to where you would paint if you had to paint this sphere. So looking at all that we have been looking at here, we are looking for the surface area of a sphere. So the surface area of a sphere is the easiest thing to remember. It is just 4 pi r squared. I know it just sounds so dumb. I forgot the squared there. It just sounds so dumb because it's like you're taking 4 circles and then whatever. But yeah, it's just how it is, you know. I did not invent math. I just learned it and then I just use it. So that's the surface area. It's just 4 pi r squared, you see. Volume is just 4 over 3 pi r cubed. So this cubed, why is it so tiny, bro? Like, who commas is so tiny? Like, what the hell, man? There we go. Let's just amplify that like goodness. Finally. Whew. Yes, like, yeah. Surface area you have, volume you have. There's really nothing much to say about a sphere. Just be able to work with it. And depending on shapes, right? When they are cut up and stuff like that, always consider that. So, yeah. Let's just move on. There's really not much to say here.